Dear students, today I'll discuss with you some important MCQ from the chapter Chemical Kinetics. First question: if the rate of reaction increases by 27 times when temperature is increased by 30 Kelvin, then temperature coefficient of the reaction is what? Okay, see, I will do question number 1. To the power 30 minus 0 by 10. Okay, so I will get to the power 3. Okay, so this is your 8. Okay, second, to the power 30, 3 the power 30, 3 the power 30 minus 0 by 10, and you will get 3 the power q is equal to 27. Okay, so the coefficient it is, that is 3. Okay, if the rate of reaction increases by 27 times when temperature increased by 30 Kelvin, then temperature coefficient of the reaction is what? So by taking the 2, you are getting 8. By taking 3, you are getting 27. So it is 27 given. So this is your temperature coefficient 3 is correct answer. Choice A is the correct answer. Next, the reaction A to B follows first order kinetics. The time taken for 0.8 mole of A to produce 0.6 mole of B in 1 hour. What is the time taken for conversion of 0.9 mole of A to produce 0.675 mole of B? Okay, so here is a trick. You see, from 0.8 to 0.6, question number 2, 0.8 to 0.6 you are getting. Okay, here 0.9 to 0.675, 0.9 to 0.675. okay, so just imagine how much it is. Okay, so see, so what is happening here? So your formula 2. K is equal to 2.303 by T log 0.8 by A minus X kitna, how much? So it's 0.8 minus 0.6, that is 0.42. Okay, similarly here you take 2.303 by T, K is equal to log 0.9 by 0.9 minus 0.675, it is your 0.225. So it is 4 times. It is also 4 times. So your time here is also 1 hour. Understand? When the ratio is 4:1, then you will get the same time. Okay, so choice A is the correct answer. Next, if A giving the product B, K1 is given this much, K2 is given this much, and product C you are getting. So find percentage of B. Okay, question number 3. The percentage of B, how to calculate percentage of B? You take K1 plus K2. Okay, so this is your 2 by 2 plus 6, 2 by 8 is your how much percentage? 2 by 8 for 25%. Okay, so choice A is the, you see, this is 10 to the q, this is 10 to the q, so this is 2 and this is 6. So by this you are taking the, so answer A is the correct answer. Okay, next, the rate constant for the reaction A to B is 0.6 multiple 10 to minus q mole second inverse. If the concentration of A is 5, if the concentration of A is 5 molar, then concentration of B after 20 minutes is what? Okay. So you see 20 minutes. Okay. So what is given? It is zero order reaction. Okay. Because moles per second inverse. Okay. Moles per second inverse is given for a zero order reaction. You take time 20 minutes. Question number 4. 20 minutes. How much second? 1200 second. Okay. So for zero order reaction, the amount of reactant consumed is K multiplied T. Amount consumed for zero order is K multiplied T. So your K is given how much? 0.6 multiplied 10 to the minus 3 into 1200. So you will get, you multiplied and you will get this much, 0.72 molar. Okay. Next, the activation energy, question number 5. The activation energy of a reaction can be determined from the slope of the following graph. Okay. So this is question number 5. So what is given? You see, K is equal to A e the power minus E by RT. Okay. Put ln both sides. Ln K is equal to ln A minus E by R 1 by T. Okay. So this is the formula. Y is equal to mx plus c. Okay. So here what is asked? This is y-axis and this is x-axis. So this is ln k versus 1 by t. So ln k versus 1 by t. So t is the correct answer. Okay. Question number 6. The initial concentration of reactant is doubled in a reaction. Its half-life period is not affected. The order of reaction is what? So out of this, C is the correct answer. Okay. Next, a reaction having equal energies of activation for forward and reverse reaction has dash. Your delta H remains as usual. Delta H. Question number 7. So delta H is equal to activation energy of the forward reaction, activation energy of the reverse reaction. So this is 0. Okay. So delta is 0 for forward and reverse reaction. So choice B is the correct answer. Next, what is the activation energy for a reaction if its rate doubled when the temperature is raised from 20 degree to 35 degree centigrade? So we'll do question number 8. Okay. So you take log K2 by K1. This is the formula. EA activation energy by 2.303 and R 1 by T1 1 by T2. This is the formula. Okay. So log K2 is equal to 2K1. It is given. So log, you are putting this value, you will get log 2 is equal to EA by 2.303, R value 8.314, T1 in Kelvin 293 minus 308. By solving, you will get the answer. Your activation energy is equal to 34.7. Okay. So your choice, this you will get this one. B is the correct answer. Okay. Next, in a reaction A plus B giving product, rate is doubled when the concentration of B is doubled, and rate increased by a factor of 8 when the concentration of both the reactants A and B are doubled. rate law for the reaction can be written as how it is written. So question number 9, you see. So this is rate and this is rate constant. This is A, X, B, Y. Okay. So rate is doubled. K, how? By taking B is 2. So A remains as usual. 2B, this is Y. Okay, let us add, this is doubled, 2R. This is equation 1. So when R2 you take, K, both are doubled, 2A X and 2B Y. This is your 8R, equation 2. Okay, now what we will do, 2R by R is equal to K AX 2B Y by K A the power X B the power Y. So you are getting what? This one is equal to 2. Okay, here you are getting what? You will get by solving this you will get 2 the power Y. Okay, so 2 is equal to the power Y, that means 2 the power 1 is equal to Y, therefore Y is equal to 1. By taking 2 and this 8R by R, you will get K 2A the power X 2B the power Y by K A the power X B the power Y. Okay, so here you will get 8, that is 2 the power Q, and this is your what? 2 the power X plus Y. So X plus Y is equal to 3. X, Y you know, this is 1. So X is equal to 2. So equation can be written as R is equal to K A the power 2 and B the power 1. So this is, I think, rate A the power 2, B the power 1. So B is the correct answer. Okay. Okay, students, have a good day.